Hey guys. So thank you to those of you who tuned in today to our Zoom conference. We had some technical difficulties where somebody who wasn't supposed to be in there decided to come in and mess around a little bit. So because of that, I had to delete those recordings and basically start over from scratch. So we're going to go through the top 4 asked questions from the worksheet practice. And then we're going to go over a couple IXL problems. What we discovered during the Zoom meeting was that some of the IXL problems ask you to fully factor, which we have not done yet. So because of that, I'm actually going to be changing my expectation of the IXL grading. I'll make sure to post all of that in Google Classroom. So the first two, or I should say that the 2 worksheet problems that had the most selections from the Google survey, thank you to the 19 of you who filled that out, were question 4 and question 7. So I have question 4 and 7 worked out here. My guess as to why you struggled with those is because these had to do with subtraction. And when you have subtraction in the middle of a polynomial, that means that you're going to end up having to change it to adding a negative and bring that subtraction sign with the first term, which would then require you factoring out a negative. I think these also gave you problems because not only was the leading coefficient negative, but it also had addition inside of the binomial. So because of all of that, that's why I'm pretty sure we chose these 2 as the ones that we weren't sure of. So I'm going to go through each one, go over the challenge problems, do some IXL practice, and hopefully that will send you on your way to being able to get this done. So number 4, step 1, put them into 2 groups. So 4p cubed minus 2p squared. Change this to addition. Subtraction sign goes with the negative 6p plus 3. Step 2, find the GCF. So over here with 4 and 2, I know 2 goes into both of them, and they both have p squared in common. So when I factor out 2p squared, that leaves me with 2p minus 1. Because 2p squared times 2p is 4p cubed. 2p squared times 1 is 2p squared. Over here, I had to factor out a negative 3 because if I don't factor out negative 3, then this will not be the same. We'll look at an example like that in just a bit because that was a question that was asked by one of the participants in the Zoom conference. Thank you for asking that question. So when I factor out a negative 3 here, negative 3 times positive 2p is how I get a negative 6p because a negative times a positive is a negative. Here's where I think you made your mistake. How do I, or when I have a positive 3, and I factor out negative 3, well, negative 3 times negative 1 is positive 3. So when you factor out a negative, it's going to change the sign. So this turns this into subtraction. I think some of you are potentially leaving that as addition. So again, I factored out negative 3 from both. When I did that, I was left with 2p minus 1. That's what I have in common, so that's what goes out in front. And then whatever I have left is my second binomial. So 2p minus 1 times 2p squared minus 3. Another good question that was brought up during our Zoom conference was, does the order matter? The answer is no. So in other words, if I wanted to change this to 2p squared minus 3 times 2p minus 1, that's also an acceptable answer. The order does not matter. In which case, and maybe in your, depending on how the answer key is written, it might have this as an answer, it might have this as an answer. They're both the same as long as you have the same 2 binomials. All right, over here with number 7, very similar to number 4. Started off with grouping, changing the subtraction to adding, bringing the subtraction sign, making that a negative 21m. 28m cubed and 20m squared have 4m squared in common. So when I factor out 4m squared, I'm left with 7m here, and 4m squared, I'm left with 5 here. So this is 4m squared times 7m minus 5. Again, leading coefficient is negative. I have to factor out a negative. When I do, that's negative 3 times 7m, and then negative 3 times negative 5 is how you get positive 15, which is why this has also become subtraction, because negative 3 times negative 5 is positive 15. 7m minus 5 is your common binomial factor. 4m squared minus 3 is what you have left over. Again, that's also equivalent to 4m squared minus 3 times 7m minus 5. Both are acceptable answers, and I'm not sure off the top of my head which one was the actual answer on your worksheet practice. We're going to go over 9 and 10 from the challenge problems on your worksheet practice, and then we'll go over some IXL code. Okay, I had a feeling 9 and 10 would be a little bit of a struggle for you guys because they had more than one variable, and you will see some IXL practice that also has more than one variable. So without further ado, here we go. Number 9, we're going to start off by putting them into groups. And what's nice about number 9 is that addition is separating them. In fact, same thing with number 10. So whenever you see addition separating the first two terms from the second two terms, you can know that you can just put your groups in. You don't have to change anything to adding negatives or anything like that. So here we go. I'm just going to put my groups right in. And you know what? While we're at it, we're going to do the same thing with number 10. So my groups are in. Step 1 done. Step 2, factor out GCF. So 3xy and 9x. Well, 3 goes into both. So I know I'm going to at least factor out 3. So that would be 3 times x times y for the first term, and 3 times x in the second term. So what do they have in common? I see a 3x in both. So that tells me I'm going to factor out 3x in the first binomial. When I factor out 3x, that leaves me with y minus 3. Now, looking ahead, you may have, if you've practiced this enough, you now know that the only way this is going to work is if I get a y minus 3 over here. So if I don't factor it out correctly, I won't have y minus 3 over here, which means I won't have that common binomial factor. So over here, we know between 4 and 12 that they have 4 in common. So that's 4 times y times y times y times y. That's our 4y squared. Minus 4 times 3 times y times y times y. That's our y cubed. What do they have in common? Well, I see a 4 and I see 3 y's. 4 and 3 y's, which means my GCF is positive 4y cubed. After I take those out, what do I have left? Well, in the first one, I only left with y. In the second one, I'm left with a minus 3. And look, I wanted that to happen. If that doesn't happen, then I can't factor out anything because it's not a common binomial factor. All right, take your common binomial factor, put it out in front. Once that's gone, you're left with 3x plus 4y cubed. Or, since order doesn't matter, you can also write this as 3x plus 4y cubed times y minus 3. All right, second example, let's look at it. 3mn minus 4m squared. First step, find your GCF because I already put them in groups. So 3 and 4 don't have any common factors other than 1. So I'm looking for something else that they have in common. And if they don't have anything in common, as we'll look at an example later on, then we can always factor out 1. So 3mn is just 3 times m times n, and 4m squared is just 4 times m times m. What do they have in common? They both have an m in common. So that's all I can factor out is m. Once I factor out m, that leaves me with 3n minus 4m. Second binomial, let's see, 3xn, that's 3 times x times n. This is 4 times x times m. 3 and 4 don't have any common factors, but they both have x. So I'm going to factor out a positive x, and that leaves me with 3n minus 4m, which I kind of already knew I was trying to get because those have to be the same. Now that those are the same, common binomial factor goes out in front. Once that's gone, what are you left with? M plus x. Again, order doesn't matter. It could also be m plus x times 3n minus 4m. Now, I'd like to say that you won't see any of these in your IXL practice, but unfortunately, that's not true. You will see some, and you will even see some that are a little bit more challenging. So we're going to take a look at today's IXL practice and do some of these together. Today's IXL practice code is HAA, like saying ha, really long. Factor by grouping. We're going to go through different levels of practice here. do some examples, talk about what happens when we factor things out correctly, incorrectly, etc. All right, so first example here on your screen, if you're following along at home, you're gonna write this example down and do it along with me. So we have 5t cubed plus t squared plus 20t plus 4. This is, again, very first question on the SMART score, one of the earlier on questions that you're going to see. All right, step 1, put in our groups. I know that it's addition, so I'm just going to put in my groups. I don't have to change anything. Step 2, factor out the GCS. So I see a 5 and a 1, so I know I'm not going to factor out a number here, but they both have t's. In fact, this is 5 times t times t times t, and this is just t times t. So I notice they both have t times t in common. T times t is t squared, so I'm factoring out t squared. When I factor out t squared from that first binomial, that leaves me with 5t plus, wait a minute, I factored out the entire term. What does that leave me with? That leaves me with 1. Second expression, second binomial, I know 4 goes into both. That's 4 times 5 times t, and this is 4 times 1. So when I take out a positive 4, that leaves me with 5t plus 1. All right, again, if these are not the same, I can't do any factor by grouping. So those have to be a common binomial factor. So altogether in our answer here, we have 5t plus 1 times t squared plus 4. Again, I like to put the common binomial factor first, because then I can go in and go, okay, I don't need that anymore. But the order doesn't matter. If you want to do t squared plus 4 first and then 5t plus 1 second, that's also totally fine. So let's go into our IXL here. So our answer was 5t plus 1 and t squared plus 4, drum roll, and we're good. So you're going to see additional examples like that. I'm not going to do this one because it's very similar to the one that we just did. I'm going to go ahead and jump a level here. All right, let's take a look at this one. So we have 6y cubed minus 9y squared plus 26y minus 39. This was a little bit tough, so I'm going to go ahead and give you a chance to try this one. As I write it down. All right, in this one, similar to the last one, it's already addition, so I can just put in my group. Step 1 done. Step 2, GCF factoring. So 6 and 9 have 3 in common, so I'm factoring out 3. And then this is 3 y's and this is 2 y's. So I know that they at least have 2 y's in common, which is y squared. When I factor out 3y squared, that leaves me with 3 times 2 is 6. And I took 2 of the y's out, which means I have 1 y left behind, 2y. 3 times 3 is 9, and I took all the y's out, so that just leaves me with 2y minus 3. 26y and 39. 26 doesn't have many factors, but and neither does 39, but I do know that they both have 13 in common. 13 times 2 is 26, and then I didn't take out the y, so it's still there, and 13 times 3 is 39, and that's a common binomial factor, which leads me to believe that I did this correctly. So when I take out the common binomial factor, 2y minus 3, I'm left with 3y squared plus 13 behind. We're going to pop over here to IXL and see if that is correct. So you know what, I'm going to change it up. Instead of what I had written, I'm going to write 3y squared plus 13 first, just to make sure IXL knows that we can change the order, and 2y minus 3. And there you have it. All right, I'm going to pause here and find another one that we can do. All right, found one that I think might be a little bit interesting. So 21h cubed minus 39h squared plus 7h minus 13. This one is a little bit interesting for a couple of different reasons. So go ahead and write this one down, pause the video, give it a shot, and then we're going to do this one together. This will be, I believe, our second to last or third to last problem that we will do together. All right, here we go. First step, put in our groups. Again, it is addition, so I don't have to worry about changing anything. So I'm just gonna go ahead and group my first two together and my second two together. 21h cubed and 39h squared. You might not think that they have a greatest common factor, but in fact they do. I happen to know that 3 goes into both. 3 times 7 is 21 and 3 times 13 is 39. So I'm gonna factor out at least 3. And then I know this has 3 h's and this has 2, which means they at least have 2 in common. So I'm factoring out 3h squared. When I factor out 3h squared, what does that leave me with? Well, 3 times 7 is 21. And I took 2 of the h's out, but that leaves 1 h behind. And 3 times 13 is 39. And h squared, I took all that out. So I'm left with 7h minus 13. Now, you might notice at this point that this is exactly the same as this. But we still have to factor something out. You cannot do factor by grouping without factoring out a GCF. You have to find a GCF to factor out. But you might be thinking like 7 and 13 have nothing in common, so it's impossible to factor out anything. Well, there actually is a number that goes into everything, and that number is 1. So you can always factor out 1. In fact, you have to factor out 1 in this case. You will not be able to resume factoring without factoring out 1. So if they have nothing else in common, they always have 1. And that leaves me with, well, I didn't change anything. Still 7h minus 13. And again, these two are the same, which is a good sign. So my final answer, 7h minus 13 and 3h squared plus 1. Let's go ahead over here to IXL, plot that in. 7h minus 13 and 3h squared plus 1. See what they say, and it looks like we're okay. All right, I'm gonna go ahead and jump a level here. Now, this IXL practice is gonna start getting a little bit weird the more that we do our factoring out. So I'm actually gonna jump one more level here to 81. Okay, we're gonna do one of these, which is similar to our challenge problems. Now, this is all the way up in the SMART score of 80, which is not going to be required for you because I'm pretty sure the answer here requires that you fully factor, which we have not gone over yet. So take a moment, go ahead and write this one down. And here we go. Now, not only does this one have multiple variables, but it also has subtractions. That means I can't just jump straight to putting in my group. I've got to rewrite it because I have to put this negative with this term. So step 1, put them into group. 6s cubed t plus 9s cubed. Change it to adding, bring the subtraction along. Negative 8s squared t minus 12s squared. All right, greatest common factor. So I know that 6 and 9 have 3 in common, but I also see something else that they have in common. I see this s cubed in common right there. That means I'm going to factor out 3s cubed because I see that they have both of those in common. What does that leave me with? Well, 3 times 2 is 6. I took out the s cubed, but the t is still there. So that leaves me with 2t. 3 times 3 is 9. And I took out the entire s cubed. Nothing else is there. So that leaves me with 2t plus 3. Now, we're going to look at what happens when you don't factor out a negative. So let's say I didn't factor out a negative and I just factored out a positive. This question came up in our Zoom meeting earlier today. Negative 8 and negative 12 have 4 in common. So let's just say I factored out positive 4 and then I see an s squared. So I'm just going to factor out positive 4s squared. This is what happens when you don't factor out a negative. 4s squared times negative 2t is how I got this one because I took out the s squared, minus 3. here is the problem, and some of you will already be able to see it. Are these the same? No, they're similar, but they're not the same. And you can only fully factor. You can only factor out a common binomial factor, common meaning same. So because these are not the same, I'm technically stuck. I can't go any further. That's why when the leading coefficient is negative, when that first term in a binomial is negative, you have to factor out a negative. Let's see what happens if I actually factor out negative 4s squared instead. Well, a negative times a positive 2t is how I get a negative 8s squared t. And negative 4 times a positive 3 is how I end up with a negative. Now are these the same? Yes. So when the leading coefficient is negative, when the first term inside the parentheses is negative, you have to factor out a negative. Otherwise, these will not be the same. Here we go, final step. 2t plus 3 and 3s cubed minus 4s squared. Now, this is a correct answer for my book right now, but IXL is going to say that it's wrong. Let me show you why. So I'm going to take this and I'm going to plug it into IXL, which is why I'm tailoring my expectations for what you're able to do. But I'll show you afterwards why IXL is going to say that this is wrong. If I come over here and I plug in my answer, 2t plus 3 and 3s cubed, oops, see, it doesn't even let me. Notice that it won't even let me do 3s cubed minus 4s squared. It only lets me do squared. So I'm going to show you why IXL won't let me do a cubed here. So let's say I couldn't avoid it and I clicked submit. It's going to tell me that I'm wrong and that this is the correct answer, which is similar to mine, but not exactly the same. So let me show you what IXL is asking you to do, which is why I'm not requiring that you get all the way up to this point. What IXL sees is that they notice that there is still some factoring that can go on here. 3s cubed and 4s squared have something in common. They have s squared in common. So if I were to fully factor this, here's what I would have to do. I would have to notice, let's see if I can fix this really quick. Thing's getting more use than it ever has. I would have to notice that these two terms still have a GCF in common. So if I put those out to the front, 3s cubed minus 4s squared and 2t plus 3, and I'm like, oh, wait a minute, these both have something in common. They have s squared in common. I would have to factor that out in order for this to be correct on IXL. Now, if you were in my classroom and we were together right now and you did this on a worksheet practice, that would be 100%. I would give you full credit. But IXL is telling you no. So if you want to try these, this is what you would do. You notice that they both have s squared in common. So I would factor out s squared. Just from these two, though, because this doesn't have an s squared. And that would leave me with 3s minus 4 and my 2t plus 3. So that's called fully factoring, which is not what we're doing right now, but that is what IXL will ask you to do if you decide to go that far. So let me show you again. There's our answer. S squared has been factored out of 3s and 4, and then there's your 2t plus 3. So once you get up past a SMART score of 70, there's a likelihood that you're going to run into this problem, which is why, again, in today's Google Classroom, I will put a modified grading scale for this IXL. All right, that was it for today. If you have additional questions, let me know. Tomorrow, we will be going over something brand new called slip and slide factoring. And with worksheet practice and a survey, there will be a Zoom conference on Thursday. Again, going over IXL problems. All IXL codes are due Sunday at midnight. Hope you guys are doing well. Have fun factoring.